Imagine a powerful car, sleek and ready to race. This car, however, runs on a special fuel data. Without it, the car wouldn't budge. This is the essence of machine learning. Data is the fuel that powers these sophisticated algorithms, enabling them to learn and make predictions. In this digital age, we are surrounded by data. Every click, every purchase, every social media post generates data. This data, in its raw form, might seem like a jumbled mess of numbers and text. However, within this chaos lies valuable information waiting to be unlocked by machine learning. This essay delves into the world of data in machine learning. We will explore what data is, why it is crucial for machine learning, the different types of data, and the essential steps of data pre-processing that prepare it for use in training machine learning models. In the simplest terms, data is any collection of information. This can be anything from numbers and text to images and sounds. For example, your age, height, and weight are all pieces of data. The words you're reading right now are also data. In the context of machine learning, data takes on a more specific meaning. It becomes the raw material that algorithms use to learn patterns, make predictions, and solve problems. Just like a chef needs ingredients to cook a delicious meal, machine learning algorithms need data to function effectively. Think of a machine learning model designed to predict housing prices. The data for this model might include information about houses, such as their size, location, number of bedrooms, and recent sale prices of similar properties. By analyzing this data, the model can learn the relationship between these features and housing prices, allowing it to make predictions on new unseen houses. Data is absolutely crucial in machine learning. It is the foundation upon which everything else is built. Without data, machine learning algorithms would have nothing to learn from. They would be like students trying to pass an exam without ever attending class or opening a textbook. The quality and quantity of data directly impact the performance of machine learning models. High-quality data, which is accurate, relevant, and representative, leads to more accurate and reliable predictions. On the other hand, if the data is flawed, incomplete, or biased, the resulting model will also be flawed and untrustworthy. Imagine training a language translation model. If the data used to train the model is full of grammatical errors or uses outdated language, the model's translations will likely be inaccurate and unreliable. Types of data: structured, unstructured, and semi-structured. Data comes in various forms, each with its own structure and characteristics. Understanding the different types of data is crucial for selecting appropriate machine learning techniques and pre-processing methods. The three main types of data are: structured data. This type of data is highly organized and easily understood by machines. It is typically stored in relational databases in the form of tables with rows and columns. Each column represents a specific attribute or feature, while each row represents an individual data point. For example, a spreadsheet containing customer information, such as names, addresses, and purchase history, is an example of structured data. Unstructured data. Unlike structured data, unstructured data lacks a predefined format and is not organized in a way that is easily understood by machines. It includes data such as text documents, images, audio files, and social media posts. Extracting meaningful information from unstructured data often requires specialized techniques, such as natural language processing for text data or computer vision for image data. Semi-structured data. This type of data falls somewhere between structured and unstructured data. It has some level of organization but not as rigid as structured data. Examples of semi-structured data include JSON and XML files, which use tags to define data elements and hierarchies, making it easier for machines to parse and interpret the data. Data pre-processing. Cleaning up the mess. Before data can be used to train machine learning models, it often requires significant preparation. This crucial step, known as data pre-processing, involves cleaning, transforming, and preparing the data to make it suitable for use in machine learning algorithms. Think of data pre-processing as preparing ingredients before cooking. Just as a chef would wash, chop, and season ingredients before using them in a recipe, data scientists need to clean, transform, and prepare data before feeding it to machine learning algorithms. Data pre-processing is essential because real-world data is often messy, incomplete, and inconsistent. It may contain errors, missing values, outliers, and inconsistencies that can negatively impact the performance of machine learning models.